Welcome to Below the Surface. I'm your host, Gunnar, and here is James, my co-host. What's below the surface?
Depends where you dig.
No, what's below the surface? As in, what kind of podcast is it? Yeah, I have to cut this out now.
This is gold, Gunnar, gold.
But come up with a tagline. I need to tell you something though. So I told my daughters about all this, and then which actor should be playing me, in other words. But they said, forget that. But you know who you are? You are Phil Dunphy out of Modern Family. I'm going, hang on a second, whatever happened to Matt Damon?
Yeah. That's like, right. Nah. They've just shattered that image that you had going on.
Okay, I'm like, well, thanks for that. Like Jason Bourne.
He's cool. Phil Dunphy's cool. He's a very lovable dad. They must think that you're a good dad.
Well, I don't know. It's hard to take that as a compliment, I have to say.
He is a bit of a goofball.
Yes.
But he's a lovable goofball. And he's well-meaning. And he's a good dad.
Because how the mighty have fallen from Arnold Schwarzenegger and Matt Damon to, hey, good. You're Phil Dunphy, my friend.
That's not too bad. I reckon that's all right.
Well, thank you. Thank you. So this time we interviewed, this is a different one because it's neither waste nor contaminated sites, really.
Yes.
I don't know. I'm such a sucker for universities. I'm a sucker for researchers and scientists.
Yeah.
And somehow this paper made it into my, I don't know if it's called a news feed, but it made it across my desk.
Yeah.
Where there is a gentleman at Macquarie University. His name is Professor Simon Griffith. And together with his PhD student, Max Killings, they have done some unbelievable research. They took house sparrows in Broken Hill. And Broken Hill, for those who don't know, is just a gigantic lead mine.
Yeah.
And they've taken lead samples of their blood, of the house sparrows, and they managed to correlate the levels of lead in the blood of house sparrows to the levels of lead in children living in that area where they caught the sparrow.
Yeah, it was unreal. They were using measurements from sparrows as a direct proxy or a surrogate for the measurement of children's lead levels in their blood. Yeah.
One would think, why don't you just measure the levels in the children?
Yeah.
But for that, you need to listen to the podcast because there's a very, very good reason. There's several good reasons for it.
Yeah.
Yeah. So I contacted Simon and he graciously agreed to talk to us. And my God, did I love that chat. Did I love that paper?
Yeah.
This is such interesting. I always wonder if I should somehow get a job at a university because I love this kind of stuff.
Yeah, it's just that kind of the purity of science and like scientific inquiry like that. I think there's a purity that comes with that is nice that we don't often get in our day-to-day work. Yeah.
Yes. Listen to it. Simon is fascinating to listen to. You will see that basically James and I, we hardly spoke because we were just listening and listening and listening. It's a fantastic interview. I'm so excited. Go for it. Oh, there is Simon. Well, that was fast.
Do we want to do any banter before he comes in?
We can't just really let him wait here, can we?
Sure, the banter's important.
Well, let's banter. What have you got planned here? I have no banter planned.
Oh, wait, do you have any punchy questions this time around?
No, no, I haven't actually. Why? Have you got something planned for me?
What were the ones? We can ask Simon as well. What were the ones we came up with the other day? I can't remember.
I'll let him in and let's see what he thinks. Which actor should play him? But just hang on a second.
Hey, Simon.
Hey, how are you?
We're good. Before, let me I'll shoot it right straight at you, right? Because I don't know if you've listened to any of our previous podcasts, but in the last two, we started talking James and I had this banter about our favorite movie characters. And I asked James if a famous Hollywood director comes along and says, hey, I want to make a movie out of your life, because it's also fascinating. But you can pick the actor who will play you, right?
Right.
So James James, you picked Jake Gyllenhaal, is that right?
Yeah, Richard Gere or Jake Gyllenhaal. I think we might.
Yeah.
Ah, very good.
Simon, I give you the opportunity. Who would you like to play you?
Well, probably not Hollywood, but no, Tony Robinson played Baldrick in Blackadder.
Oh,
You
yeah.
remember?
Yeah. Are you a Blackadder guy, Gunnar?
No, I'm not. I have heard a lot about it, but
It's still a classic. He's awesome on two levels actually, because they ran this program which I just loved in Britain for years. It was called the Time Team.
Yeah, right.
Every episode they'd go out and they'd do an archaeological dig, and wherever, like literally wherever they dug in Britain, they'd find the Romans or some Stone Age, round house, and it was just amazing. It was, and he was just really, really good. He was such a engaging host of that program.
That's awesome. Good pick. You would love Blackadder, Gunnar. I'm sure you would, because it's got Hugh Laurie's in there as well, and Rowan
Yeah.
Atkinson. Oh, yeah, great show.
isn't Stephen Fry in it as well?
Yeah.
Yeah, he was.
Yeah, okay, well,
Yeah.
you can't go wrong then, right?
No, no.
Simon, how long have you been in Australia?
21 years now.
No, okay. What got you here?
So originally I came down for a field season, and it was actually on Heron Island in the Great Barrier Reef. I was visiting a colleague down at UNSW in Sydney. He'd said, "Oh, we've got a job down here. We're just about to advertise. You should apply." And I hadn't thought about moving to Australia particularly, but it was just an amazing opportunity. I applied, got the job, and the rest is history.
Congratulations are in order, Simon. You had not only published a really nice paper, which I read, but also it made the news, which is kind of an unusual thing for a scientific paper. So who did you bribe?
I'm kind of lucky. The stuff that we do is fairly accessible. Usually I try and either write something myself in a blog, or initially we actually approached the conversation and they published something that we wrote, and that helped to generate a little bit of interest. And then the article that the ABC wrote up was actually, the journalist there had approached me for comment on something completely unrelated, and I managed to persuade her. I said, I'll talk about that, but actually, look, I'd really like to talk about this. And I think she was originally from the area around Cadia, the Cadia mine. So she had actually done a lot of work and research previously on kind of contamination issues for The Guardian. Some of the work that I do is just kind of purely out of a bit of natural history interest for the general public. But definitely for this area of work, the reason that I really got into it was to try and shine a bit of a spotlight on some of the issues.
You mentioned The Conversation. Anyone who's listening who hasn't gone to The Conversation, that outlet, it's one of my go-to media sources, really. Because, it's independent. It is strongly geared towards academic research, and science-based reporting. And so, anyone who hasn't looked at it, please go and have a look.
Yeah, absolutely.
I catch you at Macquarie University. Are you employed there? Are you do I have to call you Professor Simon, or?
You don't have to. Absolutely, no, you don't have to. But I am a professor, so I'm a professor of evolutionary biology.
Wow, another Richard Dawkins.
I'm an aspiring Richard Dawkins. Yeah. I met Richard in Oxford. I was there for a few years.
No way.
Before I came out here.
Wow.
Yeah, look, I'm very lucky. I've managed to make a career out of something that I'm very passionate about and I love. My main background is actually just in evolutionary biology. And so since the mid-90s, when I first did my PhD, actually also focused on sparrows. I've really been lucky enough to just ask questions that I find interesting about evolution. And so I'm asking questions both, what we call at the macroevolutionary level, which is trying to figure out how species actually evolve. So those are questions that, you have to look back millions of years, and you can use a variety of techniques to think about how species have evolved over time, but also microevolutionary processes. And those are literally the processes that may mean some individuals within a population will be more fit and leave more ancestors than others. And so those microevolutionary processes are ones that we can actually do experiments on. Or in this particular case with the house sparrows, we can see evolution in action as it's been occurring over the last 100 generations. So there's two things that originally got me into this contamination stuff. The house sparrow was introduced into Australia in 1853.
Yeah.
the history of that introduction was fairly well documented. I was actually interested in asking questions about how does a bird, or literally a couple of cages of birds that were introduced onto a new continent, what can we learn about evolution from that introduction? So it's like a pseudo experiment in the sense that they brought them down intentionally. They brought, just a few hundred birds down. They released them in a couple of different places. And since then, those birds have moved across the continent. They're living in very many different climates. And the climate, for example, in northern Queensland, where some of those ancestors of those introduced birds are living, is obviously very different from the climate that those birds came from back in England. Again, that was a question that's got nothing to do with anything that your listeners are probably interested in, but that's why I started working on sparrows about 10 years ago in Australia. So I'd done kind of big road trips around Australia, catching sparrows in, I think, 26 different towns, taking blood samples to look at the genetics of those birds, how they'd changed over time. And then probably just as I was doing that work, or just as we were analysing that data, one of my colleagues at Macquarie, who is very much in your area, I don't know if do you either of you know Mark Taylor?
He's on our list of please come on our podcast. Yes,
yeah,
he
yeah.
is.
No, he's great.
He was one of my lecturers when I went to university there.
Okay.
But yeah, I've long been an admirer of his, and I've seen his career journey, and obviously now he's over in Victoria as the chief scientist. And yeah, we definitely would like to speak to him. But we're a big fan of his work around the soil safe program and that sort of thing. So yeah,
no, exactly, yeah. So he's done some awesome work, and I just I saw a seminar that he gave actually about Mount Isa, and I think he maybe touched on Broken Hill, and it made me realise that we'd actually caught sparrows in both those cities. And I thought, that's interesting. I could look at the genetics because we were interested in like how sparrows might have adapted to environmental conditions. And I thought, I wonder if they're different in those towns compared to uncontaminated towns. So we did a bit of a kind of exploratory search of some of the genome data that we'd collected for that other project. And sure enough, in both of those two populations, there is a signature that those birds have adapted to the presence of heavy metals at a high level in those environments. We're in the process of kind of investigating that further, but that would be one of the first examples where a land animal has actually evolved in response to contamination in the environment.
Are we kind of talking like the individuals that are more resilient to the presence of lead, for example, are the ones that survive and reproduce, and you're seeing that over time? Is that what you're referring to?
That's exactly spot on. In those two populations, we found a higher frequency of some genes. In some cases, they're genes that have been closely associated with lead poisoning. And in other circumstances, they're just metal transport genes. So what we think is that, yes, that the individuals that are doing better in those environments, they've got some kind of physiological mechanisms which are giving them some resilience. And that's super cool. The full story we definitely haven't got, but we're working towards that at the moment. That's why I was originally interested in this lead. But then when I went and spoke to Mark, that's when I got into this idea of using the sparrows as sentinels for exposure levels and that sort of thing. But I was really inspired by people like Mark, who are actually doing stuff that's really, has much more societal benefit.
Your article made it in front of me. There's a few reasons for that. One of them, I have done an awful lot of assessment in Broken Hill.
Mm-hmm.
And it's all hush-hush. I can't talk too much about it, but it's one of the most amazing investigations, or the ongoing investigations that I have done there. It started in the 1990s and kept going. Google knows that, of course, so hence anything with lead contamination in Broken Hill would come across me. And then, of course, the podcast and my involvement here. So you went to Broken Hill and you measured the blood lead levels in sparrows, and you managed to correlate that with blood lead levels in children. Tell me more about this. So this is what this paper is all about. And to give me the background.
Okay. So again, I've actually got a long history in Broken Hill. One of the other birds that I work on, which has got nothing to do with any of this, so I'll keep it short, but we work on zebra finches, which are again, for a completely different set of research. And we've worked up at a station called Fowler's Gap, which is a research station about 110 kilometres north of Broken Hill. So I've been going out there for the last 20 years, a couple of times a year. So, of course, I'm very familiar with Broken Hill. So I actually just really like the city. I think it's a really nice place to be.
I agree.
But I've also been kind of aware of the contamination stuff. But, when I started talking to Mark, who has also been working out there for a number of years and has, he basically pulled up this map with just really nicely at a very high resolution map of the soil and the dust. And again, from an evolutionary biology perspective, it was fantastic because a lot of the people who are working on, say, birds and urban environments, a lot of people will work along a single gradient, or they'll go and measure some birds in the middle of a town and outside the town. So again, for people who aren't so totally familiar, the town's around about 5 kilometers in circumference, and it's pretty much, we can imagine it's kind of round. And of course, because the mine was founded there in the days when they didn't realize this wasn't a good idea, the CBD and all the houses are built, immediately adjacent to the active and the historical mine workings. So Mark pulled up this figure, which had all these nice colors showing areas of high lead and low lead in the dust and the soil. And I was just, wow, that's an amazing opportunity to go out there and do the kind of the world's best sentinel study. And there's two reasons why sparrows are really, really good for this kind of work. So one of them is that they're very easy to catch because sparrows are completely dependent on people. And I've been catching sparrows for many, many years. It really isn't hard. So when we were doing that work in Australia across all those towns, we would typically rock up in the town and we'd only have 2 or 3 days to get our sample of 50 birds. That would be next to impossible for pretty much any other bird. But sparrows, because they're living in people's backyards, they're coming and eating chicken food, or they're nesting in a hedge against someone's building. They're used to having people around, so they're just very easy to target. So that means logistically, you can go out there and it's not that difficult to catch that many. It was quite realistic to think that we would be able to get in the region of 40 different locations across Broken Hill, which would mean we could look at birds almost kind of block by block across that size city. There are two other things that are important about sparrows. One of them is that they have a very small home range. So a sparrow will live within an area of about 300 meters. So if you can imagine, if you go and catch a bird in this garden, that sparrow has sampled the environment with about a 300 meter circumference of that site. Now that's important because it means that the bird that you sample in that particular garden is really just exposed to any contamination in that small area. Larger birds like feral pigeons, they will tend to move around over a greater distance. So that's another really good kind of reason why a sparrow is a good thing. And then finally, the other thing that does make them good is that connection with people. So it's a story that's easy to tell because most people actually all over the world are familiar with sparrows because they've been introduced to North America. They're widely naturally distributed across the whole of Europe and most of Asia. And so most people around the world will be familiar with sparrows. And importantly, the sparrow is really dependent on people. So you don't find sparrows out in the bush in Australia. You only find them when you get into the town.
I need to take us back just a little bit. So first of all, Broken Hill. Until I started doing work there, I did not know that BHP, our massive mining conglomerate, is actually called Broken Hill Proprietary. That's where BHP comes from. And BHP started with a lead mine in Broken Hill in the 1800s and have been mining lead in Broken Hill since then. And I know exactly the map that you are talking about. It's a famous one. If you do any work in Broken Hill, you know about it. In fact, some of the data in it, I contributed to that. And it's the lead contamination in that town is, I'm missing a word here, but it is for any environmental consultant, it is just staggering. It's beyond belief how bad surface soil lead contamination is in that town. I don't know what to say there. I mean, it is close to unbelievable.
Mm.
I would immediately call for remediation action plans if I find something even half or a third or a tenth of the lead contamination I found in run-of-the-mill sites, public sites in Broken Hill. It's staggering. What's even more staggering is that the associated levels of lead in blood in the people living there, and in particular of the children living there, is also staggeringly high.
Yeah.
I know what you said, and I completely agree. Broken Hill is a beautiful place. I love it. But whenever I am there, I am washing my hands many, many times a day. Yeah, that town is amazing in many, many ways. So it is a known fact that the residents of Broken Hill have not a little bit, but they have super elevated lead levels in their blood, in particular children.
Yeah.
Why, Simon, in particular children, for starters? And secondly, what's so bad about lead levels in blood?
Yeah, obviously I'm not a medical expert, but just in the literature in terms of both people and animals, the problem with lead is that it's a metal which normally, historically animals and people would really not be encountering and not be uptaking very much. Many other metals, however, play really important roles in proteins and enzymes. So enzymes particularly are proteins that often have metals as part of the molecule of an enzyme. One of the big problems with lead is that as bodies and enzymes are being built, lead is incorporated in preference to other essential metals such as zinc or magnesium and things. And so the problem is, as soon as that lead gets into place, it will stay there. The really horrendous thing for children is that it's a neurotoxin as nerves are being developed in utero, but also really for the whole of adolescence. So we're talking, right up until the age of probably 18, 20, nerves are still being built. And those nerves, if they incorporate lead, they just won't function. And you can't clear that lead out of that nerve. It will block the neurotransmission of that nerve and the way that nerve functions for the rest of life. So it's those neurotoxic effects for children which are the most concerning. Even for the adults in those populations, however, really severe lead poisoning will get picked up. But if you have an elevated level of lead, it affects so many different physiological processes because of the way that it binds with enzymes and proteins. It will affect a whole range of things which won't necessarily be picked up as obvious neurotoxic effects of lead. So, for example, it drives the level of anemia. So you will find that people will have a slightly elevated level of anemia, and that will be chronic. So they might have that throughout a lifetime, and that's putting extra strain on the cardiovascular system. That in itself then leads to high levels of cardiovascular disease in adults. So it's estimated that it's reducing the natural lifespan of people, almost 1 million people globally every year. And a lot of these, as I say, these effects, people will go to hospital or people will die maybe prematurely, but that won't be ascribed to lead poisoning. It's not one of these things that, causes a spike in a particular type of cancer. It doesn't do that. It's causing damage physiologically to a whole range of systems. It's a particular problem in children. So we had that level of soil data and dust data that, as you say, you contributed to, Gunnar. We were able to relatively easily go out and measure the level in the sparrows across different parts of the city. And then the third layer, which was the really important layer, was the human stuff. In the early 90s, New South Wales Health started a lead monitoring program in children, which of course is really, really important. And that provided that third layer, which meant that we could overlay all of those things on top. Now, of course, people had already looked at the environment versus the child blood, but the availability of that child data that had been accumulated over those last 30 years provided that opportunity to look at, how well sparrows were predicting the exposure risk to children. Of course, people can go out there and measure the lead in different parts of the town. And then the question is, well, why do we need to worry about measuring in sparrows as an indication of exposure in children? The reason that we need to do that is because people are animals, ultimately. you can have a contamination in an environment which actually isn't necessarily affecting people. So, for example, if we dig down in the soil, we might find higher levels of lead, but as long as people aren't, disturbing that, then they're not going to be exposed to it. The benefit of using sparrows is that we're actually saying, what is the risk to someone who lives in this 300-meter environment? And the pathways of exposure for a sparrow and a human are actually relatively similar. It's the house dust. It's not washing your hands when you've been out in the garden. And then, of course, for children, and particularly young children, they are more at risk because they do stuff like they'll go outside. Toddlers will go out and literally pick up handfuls of dirt and eat it, but they're less likely to wash their hands. So it's all of those exposure channels. Of course, sparrows spend a lot of time on the ground. They will be ingesting food, which is covered in a dust that is composed of lead. But children are also kind of doing that, even if they're not, eating their dinner off the ground. They're still transferring some of that on into their bit of fruit or a sandwich or something. We do, we can measure air quality with machines. We can go and measure soil samples and things, but this is actually demonstrating that link that humans are just animals. If animals are being contaminated and those animals share the same environment, then we've got a problem.
So I don't have any experience in Broken Hill and the kind of the processes at play there. And so the source of lead in that environment, is it airborne from stack emissions from the smelters? Is that the source?
No, and obviously Gunnar probably has some valuable contribution here because he's familiar with it. So they're not smelting in Broken Hill anymore, for a start. Look, there are two sources of the lead that's being ingested today. There's obviously the historical, which was disturbed, which, is dumped in the middle of the town. And that stuff, to some extent, that stuff's becoming airborne as the environment dries out and when you get dust storms and stuff. So that's being and so obviously, and one of the things that Gunnar has alluded to is, BHP are no longer active in Broken Hill. So, of course, the current miners, they will say, well, it's all legacy lead. It wasn't us, and, we're doing the right thing. So there's certainly a lot of legacy lead, and, parts of the town were actually active areas that were being used for processing and things like that. Then there is obviously still ongoing workings, and that will be creating a certain amount of dust in the processing and the transport of that material around. So one of the things that we did in this study, just to show that it wasn't just the birds, digging it up from under the ground, we actually placed out some perspex sheets and just measured the amount of dust emissions that were contemporaneous with the sampling that we did of the birds. And in, just a couple of weeks, we were able to collect enough dust off those sheets of perspex to show that it's still becoming airborne. Again, I guess the thing about Broken Hill is that it is a very dry environment. It's also often a very windy environment as well. So that does pose a number of challenges, but even very fine particles, they don't travel very far. And that's why we get these really steep declines of lead as we move away from the mining, both the historic mining and the active mining areas. And then, of course, there's the transport corridor as well. So we've got the rail. Back in the day, it would have been moved along the rail in open wagons and
yeah, you can follow that along all the way to Adelaide.
Yeah, no, that's absolutely right. Yeah. So, and again, it doesn't go very far from the train line. I don't know exactly how far it would go, but yeah, you would be able to follow that all the way to Adelaide. In fact, Ore Pirie. So the Broken Hill ore is actually processed and the smelting operations are at Ore Pirie. Whereas Mount Isa, you have both the mine and some smelting activity in the town. So
okay, so we're looking at sparrows as a surrogate. We're looking at lead levels in sparrows as a surrogate to lead levels in children. And so main question for me, so why is it that we would use a surrogate? Why wouldn't we measure children's blood directly?
Oh, yeah. So, of course, in Broken Hill, they are measuring children's blood directly, and that's great. And I think I think that program has been really good, and they've used that program obviously to identify children at risk, to identify particular areas for remediation. I guess the good news story here is that the child blood lead in 1991 was much closer to a sparrow. So that idea that, sparrows and children are basically just behaving like two animals that behave quite similarly, that was the case back in 1991. There's still a very clear relationship today, but there's less lead in the children today compared to the children back then. I guess that's a positive sign of this kind of the monitoring program that they established, and the intervention program and the remediation, just the educational stuff, just making sure that everyone knows, if you've got kids, make sure they wash their hands, all of that kind of stuff. So the good news is that in the Broken Hill context, where we have this ongoing monitoring program, to some extent, we don't need the sparrows there. The reason that we went and did it there was we actually were it was a proof of concept. It's the classic canary in the coal mine analogy. It's like you take an animal into a toxic environment, and, you can use that animal to tell you something about the dangers of that environment. So we've demonstrated that they are a very good proxy, and we would suggest that they're a useful way of going into another town or another context where we don't already have a health problem identified, where it would be far easier to go into a town and just go and catch a bunch of sparrows and do a bit of sampling than to go in there and say, hey, can you bring your kids in? We want to take blood from them all. Both in terms of the ethics and the logistics and everything else. And you don't want to unnerve people and stuff. And again, just in the context of lead pollution and contamination around the world, there's a lot of places in the world where there's certainly no ongoing monitoring, and there's a lot of places where people probably have no idea there's even a problem. So again, one of the things I guess we would advocate is that, you can go through towns, as I said, quite easily, and just catch a bunch of birds and say, what are these particular birds telling us? And so, as well as the lead, so Broken Hill provided a really good place of saying, does this concept work? Because we had those different layers of information. We then went and up to Mount Isa. We caught the sparrows there. We measured the blood lead in the sparrows up there, and then we kind of reversed the idea, and we said, can we predict, on the basis of what we're seeing in the sparrows in Mount Isa, can we predict how many children would have exceedances in different parts of the town? And we were able to predict that perfectly. So again, Mount Isa also has a child monitoring program, so that's a good thing. But again, it helps to prove the concept that this works as a way all around the world. As I say, the sparrow is going to be in lots and lots of contexts around the world where we don't have health systems that are monitoring children. This would be an easy way of going in and saying, not only is there contamination in this particular location, but is it bioavailable? Is it available to the animals in this location? And by animals, I'm including ourselves.
That correlation that you managed to get with the data in Mount Isa, that was, to me, the total revelation in your paper. I read it and really, you got that close. That was a stunning correlation you managed to get there. I have a few just logistical questions for you. Okay.
Yeah.
You make it sound so easy, but how do you catch a sparrow?
Well, that is a good question. There would be different ways of doing it. So you can do it destructively or non-destructively. Okay. Personally, I actually love sparrows. So all of the work that we did was non-destructive. So we use a mist net, which is it's a vertical net, which is very, very fine. So it's like a fishing net, but the netting is actually much finer. And what you do is you erect it on a couple of poles at each end against something like a hedge, somewhere where they just won't see the net. If the net was in the open, they will see it. But if you put it in the right place, as they're kind of flying into that bush, they'll just get caught in the net. You can just extract them from that net relatively easily. So we'd literally drive around the town, and then you'd hear a bunch of sparrows in someone's backyard, and you'd go and knock on the door. And literally, I don't think we ever got turned away. We'd say, this is what we're doing. We're interested in these questions. Could we come and catch birds in your backyard? And when we caught them, we banded them putting a little tag on them, and then we just took a blood sample and then released them. So most birds, it would take less than 5 minutes a bird to do that sampling.
I was going to say, I'm glad you went the non-destructive route, only because I'm the same as you. I find them to be very sweet little birds, even though they are introduced, and they're not an invasive species in the way that they will not push out into,
Yeah.
native woodlands and displace other birds. And so, as far as I'm concerned, like, there's no harm in having them around.
This was interesting field work because usually when we're working, we're not interacting with people. What was really cool about this sparrow work is that, you actually get to meet a lot of people. You can talk about what you're doing. And a lot of people love sparrows. Like, a lot of people feed them. That's their engagement with wildlife. Yeah, a lot of people didn't even realize they weren't native. So yeah, we had lots of cups of tea and, slices of fruitcake while we were catching sparrows in people's backyards.
That's very nice.
Did you manage to catch some of them twice or more than more?
Yeah. So the work that you've read about, that's really this work that's looking at how well they would serve as a sentinel for this exposure risk. The other side of the work that is ongoing is actually just thinking about what the levels are like in these sparrows. These sparrows had levels of lead in them that were off the charts. Like, lead poisoning in wildlife is an issue. There's lots of studies around the world, particularly things like birds of prey and a lot of waterfowl have been studied for many years through exposure to lead, particularly lead pellets or lead fishing tackle. We have a good idea from the literature about what the levels of lead are in blood, where birds start getting chronically sick and then acutely sick and then dying. And normally when you get to about 50 micrograms per deciliter, that would be, you'd start seeing birds brought into vets that are really sick. A lot of these sparrows that we were catching, so there was nothing, they weren't sick, we were catching them, they were going about their business completely well. The highest levels we had were over 120. So they're probably twice as much as birds that are being taken into vets that are really, really sick. And so they're probably kind of the highest levels of lead in blood that have been detected around the globe. And that comes back to your observation earlier, Gunnar, about the very, very high levels in Broken Hill in the environment. Yeah, so with respect to your question, yes, we did catch birds. So even some of those birds that had really crazy high levels of lead, we caught them like a year later, 2 years later. So it wasn't that this is making them sick and they're just kind of dying. So again, that is some support to the idea that in Broken Hill particularly, these birds have some kind of resilience. And so what we're trying to understand at the moment is, what are the genes that are conferring resilience to lead poisoning, and what are the pathways through which these birds are suffering normally, and that these ones are apparently managing to kind of cope with these very high doses.
When we correlate that back to humans, a level of 50, that person would no longer function.
No.
There is no safe level, but the alarm bells seriously start ringing when you get over 5.
Yeah, no, absolutely. So look, these birds were really off the charts. We measured the lead in the blood from probably about, I'm guessing, over 1,000 birds out there. There were very few that were kind of undetectable. Most of them were, the average level was about 50.
So just to recap, so you've got now a model, I guess, where you can go to new locations and capture sparrows and blood samples, and then create a model or like a prediction as to what blood lead levels will be in children in that area.
Yeah.
What are the next steps in terms of applying that model? And also another question, is there a view that other contaminants could also be looked at in this way?
Yeah, absolutely. Great questions. And yes, so we went to New Caledonia and we did some work out there in Noumea.
Oh, nickel.
Yeah. So they've got really big contamination issues with nickel and chromium. And again, Noumea, that's it's a beautiful place. The island's beautiful, but it's essentially just a great big nickel deposit as far as I can see. And they've got the processing plant right in the middle of the city, or pretty much in the middle of the city. And you just drive past it and you can just see the dust just kind of billowing out the top of this. So again, we went out there and we did exactly the same thing. We caught a whole bunch of sparrows around that city, and again we've got the prevailing wind. We have some of these maps, and we gathered our own dust and soil samples. We've kind of demonstrated that it works for nickel and chromium. contaminants like nickel and chromium, there's actually not been very much work done. Like I was literally just earlier this week, we took a sperm sample from those birds. They some of those birds have just completely destroyed sperm, so they would have been completely infertile. Biologically, there's no real difference. If something's damaging the sperm of a sparrow, it's almost certainly going to be damaging the sperm of a person as well. Because a lot of these physiological processes that are being damaged, they're really fundamental.
Yeah.
And so they're affected in very similar ways. So we went to a small town where there was the ore deposit up in the hills, and then they were driving uncovered trucks down from the hills and then basically through this little town and then down to the port facility. And right next to the trucks, there was all the kids waiting for their school bus. Again, just off the chart levels of contamination. So that was pretty horrendous to see. So yeah, we've done nickel. We've also looked at fluoride down in Portland in Victoria, associated with an aluminium smelter. And then currently Max, a PhD student who's working with us on this project, Max Gillings, he's actually working with the Victorian EPA looking at PFAS. Again, is the new thing that we should all be worrying about. Just showing really nicely that the gradient of PFAS in the environment is really nicely captured by the sparrows that are moving around and flying around in that environment. I think it's safe to say that they are a good model for capturing a whole variety of different contaminants.
Really, really interesting to know that it can be used in those different ways. Like it sounds like there's quite a broad range of applications that we could be looking at.
Yeah, so there's definitely a range of different applications, and they provide the opportunity to identify different contamination hotspots. But then the next thing that I'm really interested in exploring is if we can use the sparrows to identify some health effects. So, for example, in those broken hill birds, we measured, as well as measuring the actual amount of lead in the blood, we actually measured the amount of hemoglobin, which is a measure of anemia. And so anemia is something which has been associated with lead poisoning in people. And sure enough, we found that the sparrows in the very contaminated areas had higher levels of anemia. It enables us to actually demonstrate that if the sparrows have health effects like anemia in the broken hill sparrows or damaged sperm morphology in the Noumea sparrows, it's kind of an easy way to go in and say, okay, we've identified a health problem, and particularly for things that we don't fully understand, like nickel, where there's a whole bunch of things that could be going wrong that we don't really understand. But again, we can take that analogy of the canary in the coal mine and we can say, these sparrows have got problems with them. They are just, humans or mammals and birds are actually, once we start thinking about the way tissues work and the way that these physiological processes work, there's no reason to think that humans are going to have some kind of magic beans that protect them against the similar problems. So that's what I'm really interested in exploring further. It's actually just, as well as saying they're contaminated, it's like they're also sick, and they're sick in this particular pathway that's been damaged. I mean, that the broken hill thing is it's interesting because it's such a good natural laboratory of lead poisoning.
Yeah, if that's what you want to call it, yeah.
Well, but as you described earlier, it really is, isn't it? It's like the levels are really high. There's lots of variation across the town. And yet, as far as I can see, there's not really very much medical work happening in that space. And again, that's not my area of expertise. It just feels like there should be more people out there saying, how are people being affected?
The answer is in your paper. The graph that shows the children's lead blood levels in correlation with tons of lead mined is just, you need to look at the absolute numbers. This is crazily high. These children lead levels are out of this world. And it was one of the most fascinating projects I've worked on for many years. And it's also one of the most frustrating ones because look, Simon, I have so many other questions that I would love to ask, but we have to finish this off. First of all, James needs to go for starters, right? So,
I'm really sorry, Simon. I've got 3 under 3, and I'm on daycare pickup. So
rescue them from daycare. I know.
I got to stop doing this. This is my fault because we started a little bit late. So look, I'm going to jump off. I thank you so much for your time.
Yeah.
I know Gunnar, I've got a couple of burning questions about XRF because we love XRF work as well. So I might just leave you to that if that's okay, but I really appreciate your time, Simon. Thanks very much, Simon.
All right, nice to meet you. Thanks, James.
Catch you later on.
Yeah, I won't bore you with the XRF questions or anything else. I just wanted to quite honestly say that I really enjoyed your paper. There's so much, my God, has there a lot of work gone into this. You know, when we write our environmental reports, we're all proud but then you come along with this paper and I can see that not only doing the work and the field work, but the presentation of the data, the collating of all the references, and that was, I can see in that paper the enormous amount of work that has gone in there, and you've done such a great job.
Well, I should definitely pass that on to Max. So he's the student. This is his PhD work, and he's phenomenal. You know, I've been really lucky that sometimes you just luck out and you get a student that you don't really need to teach them very much. You just give them an idea and they run with it. And Max is like that. He's excellent. He had previously worked with Mark. So the thing that has been fantastic about this study really is just the opportunity to work with really good people. You know, Mark in particular, his years of expertise and stuff like that coming into a project like this has enabled us to do work on a level that I am very happy with, but I won't take very much of that credit.
So give us Max's full name, so he needs to be credited here.
Yeah, so it's Max Gillings. I mean, he's great. I know, like, you should definitely get Mark on. Max will be a superstar in the future, I'm sure. He's really good. He's very driven. He's doing an internship with the Victorian EPA. And as I say, he's kind of broadening his space. Yeah, no, he's excellent. So yeah, full credit to Max.
Simon, congratulations again. Really, this is a great paper.
Well, thanks very much. I'll pass that on to the others.
And thank you so much for your time. I so enjoyed this.
Nice to talk to you. Thanks very much, Gunnar. All right. See ya. Bye.